Good morning, all. In this particular lecture, we will be discussing some of the fundamental things. Some of those we already covered in previous section lecture, that is reasoning, problem solving. But we will quickly go through those concepts. Along with that, we will start with knowledge presentation, planning, learning, perception, motion, and manipulation. So as we discussed, the reasoning is a process of deriving logical conclusion and making predictions from the available knowledge, facts, and belief. Or reasoning is a way to infer facts from the existing data. So what we understood from the definition is that whatever information, beliefs, or facts are with us, we process that data in order to draw some valuable conclusion. And that conclusion may be in terms of some kind of decision making or any other reason. Again, there are different types of reasoning. Okay, so we will see one by one. First one is deductive reasoning. So what we do in deductive reasoning, in this, new information from logically related known information facts it utilized. For example, suppose we know one fact that all human eats veggie, that is all humans are vegetarian, and we also know that Suresh is a human being. So if this particular part is known to us, then we can conclude that the Suresh is also a vegetarian. So some facts or information is available with us, and from that information we conclude that Suresh is a vegetarian. So this particular approach is called as deductive reasoning. The second part is inductive reasoning. So from definition point of view, the inductive reasoning looks similar to deductive reasoning, but there is a difference. So inductive reasoning is also a form of reasoning, and it will help to draw some conclusion, but that conclusion is based on limited set of information or facts, and based on that limited data set, some conclusions are drawn. For example, if you visit a zoo and if you found that the penguins are of white color, okay, so, and similarly if you visit 2-3 more zoo and you again find that penguins are of white color, then you draw a conclusion based on the limited data set that the penguins are of white color. So in this case, the data set is very limited. So again, if the size of the data changes, the conclusion may get changed. So this is the basic difference between deductive reasoning and inductive reasoning. The next part is abductive reasoning. So again, it is a form of logical reasoning which start with single or multiple observations. This particular part is very important. Then seeks to find most likely explanation or conclusion from the observation. Okay, so here we use the past data as well. So suppose if you found that the cricket ground is wet, then you may conclude that the ground is wet because it is raining. So there is a rain. That could be a justification we can provide based on the single or multiple observations. Then the fourth type of reasoning is common sense reasoning. So common sense reasoning is an informal form of reasoning which can be gained through experience. So this particular part is mostly related to the past experience that a person or a system gets. So for example, one person can be at one place at a time. So that is obvious, and over the period of time we learn this. And if somebody says a single person is at two different places, then we don't believe. because we know the fact that one person can be at one place at a time. Second example could be, if I put my hand in fire, then it will burn. That is also very common sense. So this is another type. Then the fifth type is monotonic reasoning. In this case, once the conclusion is taken, then it will remain same even if we add some other information to the existing information in our knowledge base. For example, Earth revolves around the sun. So this is a monotonic reasoning, or this is the fact. And if the temperature of Earth increases or decreases, it doesn't affect on this particular statement, that is Earth revolves around the sun. So if we add some external thing to it, or if you remove some of the part of the existing thing, then the state of the system will not change. And this particular reasoning is called as monotonic reasoning. On other hand, there is another type which is called as non-monotonic reasoning. So in contrast to the monotonic reasoning, so here some conclusions may be invalidated if we add some more information to our knowledge base. Okay, so whatever conclusions we are drawing here, it will affected by external parameters. Right, for example, suppose we know that birds can fly. That is fact, we know. Second, penguins cannot fly. This is also known to us. And suppose PT is a bird, PT is a name given to a particular bird. So we can conclude that PT can fly. So we logically connected different parts. Okay, PT is a bird and we know that bird can fly. And therefore we are concluding that PT can fly. Suppose in next case, PT is a penguin. Then the conclusion will not remain same. Now we conclude that PT cannot fly because it is a penguin. So this is a non-monotonic reasoning where we change certain input parameters. That earlier PT was a bird, now it is a penguin. So the conclusion will get changed. So these are the 6 types of reasoning, and whenever you are trying to train a machine learning algorithm, then we need to find out which type of reasoning we need to implement in order to draw some conclusion or to train the system. Second fundamental thing is problem solving. Okay, so early researchers have developed algorithms that imitated step-by-step reasoning that humans use when they solve puzzles or make logical deductions. So for example, in this figure, you can see that there is one conveyor on which jobs are continuously moving, and there is another station, we can say, and in between you can see there is a robotic system. And the purpose of this robotic system is to pick and place. So it will take the component from one conveyor and it will place on other station. So it will first of all go to first workstation, it will pick it, then it will find out the path and it will paste to the another place. So this is the step-by-step learning, and in today's AI and machine learning systems, we generally see such type of system which works on the fact that there is a algorithm which works step by step. Okay, so this is very traditional and commonly seen application of problem solving. Then in 1980s and 1990s, what we saw that AI research had developed methods for dealing with uncertain or incomplete information. In previous example, what we have seen, everything is known to us. From where compound is to be picked, we know. Where compound is to be placed, that is also known. But if there is a situation where uncertainty is there or information is not complete, Then in that case, we apply the laws of probability and economics to carry out the task. So this is the extended version of the simple step-by-step reasoning. And here we can take the example of predicting the economical growth of India. So there are so many parameters involved in the economical growth of the India, and it is also uncertain because just before COVID we were saying that the Indian economy will grow more than 10% rate, right? But because of the entry of the COVID, it hampered a lot. So there are some uncertain or incomplete information available. Again, we will take another example. Suppose you have a four blocks, say A, B, C, D, and your goal is to place in such a way that first of all the A block would be there, then B, then C, and then D. So if we train a model based on the given location of blocks A, B, C, D, then it will work appropriately and you will achieve your goal that the block B will be after block A, C will be after B, and D will be after C. But if a new situation is given to it, so you can compare the initial situation 1 and 2. So the blocks A, B, C, D are arranged in a different way. Then the same algorithm will not work and you will not get A, B, C, D arrangement, which we can see in our goal. So here unpredicted thing is there. So here the role of problem solving come into the picture. We need to train the algorithm so that if a new situation is given to the problem, then logically it should make a decision so that the expected goal can be achieved. Okay. Then again, in 20th century, what is observed that the whatever simple step-by-step reasoning or uncertain or limited information is available, then this will not work for, especially for the complex system, because step-by-step reasoning is very slow process and it can be applied to simple systems. For example, pick, pay and place robots. For example, suppose you are traveling or you are driving a car and suddenly another car came in front of your car. So in that case, you will not apply a step-by-step reasoning, or you don't have time to do the process in step by step, how much brake is to be applied, how much we need to deaccelerate and all these things. Within a fraction of second, you make all the do all the process and draw some conclusions so that you can control your car and you will minimize the probability of accident. So in this particular example, the time available is very small, and here you cannot go with the step-by-step reasoning. Okay, again in this case, you may have incomplete information that you cannot exactly judge with what speed that other car is coming in your path. So you need to deal with all uncertain situation as well to make a decision. So this is another approach of problem solving. And today we talk about autonomous car. So in that case, certain predicted situations will come and your system will be in a position to take appropriate decision. Then the next part is knowledge representation. Okay, so whatever we learn or whatever system will learn, that should be presented in such a way that the others will come to know. And this particular part is called as knowledge representation. And there are so many AI programs which are available, which present the knowledge in such a way that it will easily communicate whatever knowledge is there to the audience or to other system. So basically, knowledge representation is a study of how beliefs, intentions, and judgments of intelligent agent can be expressed suitably for automated reasoning. So here, when we say intelligent agent means either it will be a intelligent system, for example, robotic system, or it can be a computer program. So that is called as intelligent agent. So what will be its role? Based on the learned things or beliefs or information which he earned in the past, based on that he should make a decision or present the knowledge in a very systematic way. So last time we saw this example, suppose your pen is not writing, then you can find out it could be due to the external reason or it could be due to internal reason. And external reason could be the broken cover or a thread failure, and the internal reason could be the refill failure, that is refill is empty, or the pointer may get failed due to human mistake. So this is how we can find out the root cause why your pen is not working properly, and slowly we will go towards the root cause. So this is one of the approach of presenting the knowledge. And instead of a description form of knowledge representation, it is always good to use either a flow chart or a diagram or a table to present the knowledge. So new way of presentation should be there, and whenever we are designing AI-based program or a system, the knowledge representation should be such that the communication will be very easy. Again, the knowledge representation can be classified into different types. First one is declarative knowledge. Okay, for example, COVID protocols. So all the rules and regulations which are given to the community, especially in the pandemic situation, these are the declarative knowledge. And you just read those declaration and follow accordingly. And it may include the concept, facts, and objects and express in a declarative sentence. Second type is structural knowledge. It is a basic problem solving knowledge that describes a relationship between concepts and object. So the structural knowledge identifies the relationship between the variables and accordingly the knowledge base is developed. For example, relationship between temperature and human performance. So what we know that as temperature increases, human performance decreases. So human performance, let's say H, and temperature T. Then as temperature increases, human performance decreases. So that kind of relationship can be developed, and based on that decision can be taken. The third one is procedural knowledge. So we know that while solving the problems of root of the equation, you followed a certain step-by-step procedure to solve the problem. So the AI system, the role of the AI system could be for solving a given particular problem, it has to follow a particular procedure. Okay, and based on that procedure, it will take some decision. So algorithm development based on that algorithm coding to be done. So accordingly, work can be completed. So it is called as procedural knowledge. Next one is meta knowledge. So meta knowledge defines the knowledge about other type of knowledge. For example, if you make a statement, then sometimes you give some references. For example, if I say that tomorrow is a holiday, and I will give here the reference of the notification that we received from the institute. So here I am quoting that tomorrow is a holiday is the statement not made by me. I am making this statement based on the notice that we received from the institute. And such type of meta knowledge or bibliography you can see in the study books, where some important conclusions are cited. Again, heuristic knowledge. So it is just called in meta knowledge with reference to some other textbook or other knowledge base, you are making some conclusion. However, in case of heuristic knowledge, you perform the experiment, you carry out your own study, and based on your study, you are making some comments. For example, the boiling temperature of the water is 101 degrees Celsius, and this is your conclusion that you drawn from your experiment. Okay, so in simple word, heuristic knowledge represents some expert knowledge in the field or subject. So we have seen the different types of knowledge represented. First one is declaration knowledge, where certain declarations are there, you need to follow it. Then structural knowledge, where relationship between different things are identified. Then if certain activity is to be carried out with the procedure, then it is called as procedure knowledge. Then we are defining certain things based on some reference material, then it is called as meta knowledge. If we are drawing some conclusion based on our own experiment, then it is called as heuristic knowledge. Then next part is planning. So this particular activity is very important because in knowledge presentation, we present the behavior or the training of the AI system in a very systematic way, and that should be understandable. Okay, so in planning the task of coming out with sequence of action, and that sequence of actions are defined or planned to achieve certain goals. Okay, so three things are very important here. First, search best problem solving agent. So we need to find out this agent and train accordingly. Then logical planning agent. So that agent or that AI based system should plan the activity accordingly. Either the problem is simple or a complex. For example, in our day-to-day life, we do so many activities. So in this particular figure, you can see that these are the logical presentation of the activities, and all this data is stored in our brain. And suppose on a given day, if you if you need a milk, then what you do, the first activity that you do, that you compare all the information stored, that either you need to go to pet store or school or supermarket or what, in order to go buy the milk. Then your brain, based on your prior information, tell you that you need to go to the supermarket. And again, when you go to the supermarket, there will be so many things available, for example fish or any stationery or milk or anything, and your model is already trained for the identifying the milk, and accordingly you will buy the milk and you will come back. So this is how the planning is to be made, that where to go, how to identify the milk, and how to procure and complete the task. So the intelligent agent or system that can plan makes a representation of the state of the world, makes prediction about how their actions will change it, and makes choices that maximize the utility of the available choices. So whenever you are designing an intelligent agent or a system, you need to develop such type of knowledge representation, and accordingly it should be trained. And your agent should be in a position, if certain situation is given to it, for example buying the milk, it will identify the best path, or it will identify the best plan to accomplish the task. The next part is learning. So here I will not be explaining the learning part in detail, because in afternoon session we will be discussing the concept of machine learning. and its classification. That's why briefly we will cover machine learning. So as we already discussed that AI is a very general term, and it is developed in 50s, especially after World War II. And in 70s, 80s, the focus was shifted to machine learning algorithms. And from the word learning itself, we can say that the systems or the programs should be designed so that it will learn itself and make the decision accordingly, and less emphasis should be given on the programming or improving the algorithms again and again. So your machine learning algorithm should learn through the experience and make a best decision. Again, we know that, or we will discuss that machine learning can be classified into unsupervised learning, where for a given input data, patterns are identified, and based on the pattern, the decision is made. For example, if there is a dog and there is a cat, so your machine learning algorithm is trained for the different patterns of the dog and different patterns of the cat, and based on that pattern the machine learning algorithm can make decision. So in this case the data is not labeled, that it will not know that this is a dog and this is a cat, only it knows the pattern. In other case, in supervised learning, the machines are trained for label data, that different images of dogs are provided as an input, and the model is trained that this is dog. Again, several images of cats are given as an input and the system is trained, and after training, later it is checked that whether if unknown image is given to it, whether it will say that this is a dog or a cat or something else. Again, in this particular approach, the classification is one of the things. So classification is used to determine what category something belongs in. The program sees a number of examples of things from several categories, and then it will learn to classify new inputs. So just like if we train the machine learning algorithm to detect a dog and a cat, then it will classify the things, and when new input is given to it, it will classify accordingly. If it is dog, then it will go in that category. If it is cat, it will go in that category. Again, sometime the regression analysis can also be used. For example, we already discussed that as temperature increases, the human efficiency and decreases, right? So that can be regression approach can be used to make certain kind of decisions. And one of the outcome could be that whenever the people are working at a workstation, then what could be the optimum temperature of that workstation so that that human can perform with its highest efficiency. Again, another type of machine learning is reinforcement learning, and the agent is rewarded for good responses and punished for bad ones. So again, there is a separate chapter, that is, I guess, chapter number 5 is there for reinforcement learning. So we will discuss the concept of reinforcement learning in detail in that unit. Again, unit number 1 also in afternoon session we will be discussing the same. Again, transfer learning is when knowledge gained from one problem is applied to a new problem. Okay, so when one situation is there, one knowledge base is created, and when similar situation comes in case of a new problem, then that knowledge is transferred there and the problem can be solved. Then next part is computational learning. The computational learning theory can access assess learners by computational complexity, by simple complexity, or by other notions of optimization. Okay, so this is related to assessment approach. Then we will go to types of learning. The first type of learning is rote learning. So this technique mainly focuses on memorization of the things, and it will not consider the inner complexity, so that easily the things can be stored. For example, many times we memorize the poem or a song even though we don't know its meaning. So this particular example is a rote learning, right? So without knowing the meaning, the system is trained to memorize it. So it is called as rote learning. Then in case of inductional learning or learning by example, so here a general rule is induced by the system from a set of observed instances, and it is also called as supervised learning. So different situations will be given to you, and based on that whatever observations will come, based on that the system will be ready to make some decisions. For example, as temperature increases, work efficiency decreases. So from this learning, one important conclusion can be drawn, that at what temperature the performance of or the efficiency of the workforce increases. So that's why generally a temperature ranges between 22 to 28 is maintained, especially at the workplaces, in order to get the maximum work out from the human being. So this is the approximate range. So that can be a learning process, and based on that learning process, the decision can be made. Then learning by taking advice, this is another type of learning. So in this type of learning, a programmer writes a program to give some instructions to perform a task to computer. Once it is learned, the system will be able to do new things, right? Just like we take the expert opinion. For example, when you start working, which is the best engineering college for your marks, then you also start identifying different colleges, then along with their cutoffs and all this information, and you can make a decision. But again, if you found that there are 4 5 colleges where you may get admission, then next step what you do, you ask the faculty members who are working in that institute, you personally visit that institute, take advices of the past students, and based on that decision can be made. So along with your knowledge, some external advice is also essential, and this will help in improving the knowledge base. And in other words, we can say that it is an improvised version of the rote learning, wherein rote learning, we never understand the inner complexities. We just memorize without understanding its meaning. However, in case of learning by taking advice, it is the next level. Then explanation based learning. So from word itself, we can say that it deals with an idea of single example learning. Then learning by problem solving. Okay, so a simple example can be taken, that we learn the estimating the roots of the equation. Okay, and suppose if you solve many problems by using roots of equation, by to estimate the root of the equation by using bisection method. So when you solve n number of problems, then you will come to know that for a certain set of equations, the bisection method is more effective, and in certain problems you cannot rely on bisection method. In that case, you need to go for Newton-Raphson method, or you may conclude that the accuracy of the bisection method can be increased by Newton-Raphson method. for a certain type of problems. So this is the example of learning by problem solving. So these are the different types of learning. If the learning takes place just by mugging, then it is called as rote learning. Then based on certain relationships and observed data, if we are learning, then it is called as inductive learning. Then in certain situations we take the advices, so it is called as learning by taking advices. Then explanation based learning is also there, and again learning by problem solving. Again, in previous classes we already discussed about natural language processing. For example, suppose you write a one page, write upon a particular content, and you know that your English is not up to the mark. So in that case, what you do, you take the help of Grammarly. So what Grammarly will do, Grammarly try to identify the mistakes in your text, and it will recommend you certain modifications. And the question here arises that how that Grammarly will come to know where is the grammatical step. So basically the logic behind it is the Grammarly app is trained for different situation, and especially the grammatical one. And when it will start reading the text that you have written, then it will compare your write-up with some well-defined trained models, and the places where it identifies the problem, then it will suggest some recommendations or modifications. Then again you can take the examples of other apps, for example Siri or Alexa. So when you say something, Siri play song XYZ, then your voice command will be received by that app, and that app will compare your statement with already well defined algorithms, and it will understand what exactly you are looking for, and based on your command it will play the song XYZ. So this is another example where voice command is given as an input, and that is processed and converted into automatic or appropriate language. Again, we can take another example. So few years back, for example, 2005 to 10, what we were experienced that if we don't know a Marathi English word for a particular Marathi word, and if you put the same word in the Google box, that what is the meaning of, let's say, uh, any word you can take, for example cow, okay, the Marathi word of cow is guy, then the Google will not be in a position to understand what is the English word of that guy, that is cow, and it will show some wrong results. But over the period of time, the Google system is developed for language processing, and it is trained that if a particular word is there in Marathi, what will be its meaning in English, and accordingly the uh, English word is connected to it. So if you search cow guy on Google, it will automatically come to know that you are looking for a cow, and it will show the corresponding options to you or search windows to you. So this is how the different natural languages processing techniques are coming, that either process the voice to text, or it will understand your voice command, it will help you to improve your communication skill. Again, in our new channel also we see that there are certain apps which help you to improve your pronunciation, because our pronunciations are significantly influenced by our native language, so we pronounce English words accordingly. But the pronunciation made by the European or American people are totally different. And if you want to get those accent, then there are certain apps where when you speak something, it will understand which mistakes you are doing while pronouncing the words, and it will tell you that these are the areas where you need to improve, and accordingly you can improvise the thing. So these are the some of the examples of natural language processing. Again, last week I was discussing with one of the students. So in while solving the problems of roots of equation, okay, so generally when you wrote a program and run it, then it will ask you enter first approximation of the root, and you enter some value. Again, next time again it will ask enter second approximation of the root, again you enter the value. So this is the text-based display. Now that student developer wrote the code so that if you give a voice command, then it will understand that what you are telling, that is first approximation of the root. So you said 15, then your voice command will be converted into the number and the program will take it as a input. So this is how slowly things are improving, and we also think about developing a such type of system. Again, perception is a very important part. Yeah, so generally whatever inputs are taken by the sensors, for example face recognition system is there. So what is done in that? So it will, the input is given as a profile of your face, and the system will come to know that this person is XYZ. Okay, but such type of data is generally used to identify a person, but it will not find out the behavior or the approach. Okay, so we need to think about, based on your facial expression, what would be your mood. Okay, so in facial recognition system, cameras are widely used. So again, an unknown image is given to it, or a situation is given to it, then it should recognize what is the behavior or what is the mood of a person. So machine perception is the ability to use input from sensors, and the sensors could be cameras for face recognition, microphones for speech recognition, or other kind of signal, for example wireless signal or active lidar, sonar, radar, tactile sensor. So these are the different sensors which convert the given information into other signals, so that some processes are carried out in order to identify certain object or perception. So for example, computer vision is the ability to analyze the visual inputs. So when images are given to the computer vision system, it will process and produce some output, what kind of situation is there. Then motion and manipulation, especially when we deal with the robotic system, then the motion and manipulation come into the picture, because there is a physical movement. For example, one object is there, let's say A, at workstation 1, and it is to be placed at other workstation, let's say B, and there is a pick and place robot. Okay, so in this example, motion and manipulation, both things come into the picture. Okay, so first of all, it has to identify the location of object 1, A, and it can be done either through a map or Google Map or some other location devices, and accordingly the arm of that robot will reach to object A, and it will sense that how much force is to be applied on object A in order to pick it properly without damage or without any kind of accident. Then again it has to check at what place the object B is there. So accordingly that motion needs to be done, and the system should be in a position to identify the shortest distance to place the component A at workstation, let's say B. And this is where the Google Map or the movement or manipulation come into the picture, and a decision is made so that in shortest time the component or the object will be placed from workstation A to workstation B. Again, suppose there is one shortest route to place the component A from first workstation to another workstation, and it is observed that there is an obstacle in between. Then what is done? The robotic system will choose another path to place the component to position B. So such type of motion and manipulation needs to be planned appropriately, and for those the location through Google Map, the positions of the objects and the robots or its systems. So these things help a lot for motion and manipulation. And the ultimate aim of designing for motion and manipulation is that whatever activity is to be carried out by the robotic system, it should take minimum time to complete that task. Okay, again, the robotic system should learn from its past experience how to move efficiently despite the presence of friction and wear system. For example, at station 1, suppose a metallic component is there. And then the robotic system, based on past experience, should understand how much force it has to apply to grip it properly. And then while placing the component on another workstation, it should decide from what height it should drop the component or how to place the component at another station. Again, in next type, suppose instead of metallic component, suppose glass component is there. Then the system from its previous experience should learn that the component is different, and accordingly it should modify the force with which it is to be lifted. And again, while placing to another workstation, it has to understand how it should be placed at other workstations so that there will not be any kind of damage. Again, we are talking about social intelligence as well. So in one of the class, we discussed that when we talk about futuristic artificial intelligence, in which we are talking about processing or simulating human feelings, emotions, and mood. So that comes under the social intelligence. For example, suppose you want to play a particular song on Alexa, and you say, Alexa, play song XYZ, and sometime it happens that she will not be in a position to understand your song and she plays something else, and you again try in a different words to play that particular song, and again the same problem that Alexa will not understand. So after some time you get angry and you say something to the Alexa, okay, wrong words, but she will not understand. She says, sorry, I don't know what are you talking. So what we understood from this example, that the AI system will not understand what are your emotion or mood. So she is saying something based on whatever knowledge or database she has or it has, and based on that decisions are made. But when we talk about the futuristic system, it should understand the your feelings, emotion, or mood based on the voice toning or the intensity with which you are talking, and accordingly it should act. So all this part comes under the social intelligence. Again, along with the social intelligence, general intelligence is also there, where a machine with General intelligence can solve wide variety of problems with a breadth and versatility similar to human intelligence, doing simultaneous activities. So these are the examples of general intelligence. There are several competing ideas about how to develop artificial intelligence, especially when we are dealing with the general intelligence. So a lot of research is going on in this particular direction. Okay, so ultimate aim of the developing general intelligence or social intelligence, the research is focusing on, can we simulate or can we develop a system or artificial brain which can simulate or behave just like our human brain. Okay, or develop a system for carrying out various activities just like we human do. And this is a bit of complex behavior, and when we start developing such type of devices in order to solve such type of problem, then it will come under general intelligence or social intelligence. And some of the name of the researchers can be seen on your screen who are trying to develop or working on it. Okay, so that's it from my side for today's session. And okay, so that's it from my side. If you have any question, the session is open. Yes, anybody has any question?